Alright everybody, welcome back. This is our last lesson on radicals, where we start to talk about solving radical equations. We talked last time about simplifying some of those expressions, but now we got to put everything together and start to solve some things. You can find the link to this file in the description box underneath, full solution key as well, if you want that, all filled in and everything. So let's get to it. We'll fill in these blanks here first before we start talking about some specifics. You can solve equations involving square roots and cube roots using what we've called before opposite operations. Right, so like we've done in the past, in order to get rid of some things, maybe if there was addition, we would get rid of it by using subtraction. Same idea, but we're going to use opposite operations, in terms of radicals. So when you solve an equation with a variable in that radical first, you're going to isolate the radical on one side of your equation. Essentially, we want to get it by itself before we get rid of that square root, or cube root for that matter. Then we can square both sides of the equation if that radical is a square root, or cube both sides if it's a cube root. So the index will tell us what we're going to do. Then we're going to solve for the variable as we would normally. So once the root sign's gone, it turns into a regular old equation that we can deal with. Now, a couple important things. Squaring a number is the inverse operation of taking a square root, and I guess cubing a number is the opposite operation of a cube root. So when we think about getting rid of those root signs, it's not necessarily a divide by 2 or divide by 3. Really, the opposite operation to a root sign is the exponent that will go with it. So square roots are based on powers of 2, cube roots based on powers of 3. And when you solve an equation with a variable in the radical, we need to restrict the variable to ensure the radicand of a square root is non-negative. Remember, we can't take the square roots of negative numbers. So we need to come up with a restriction on our variable, because we don't really know what x is going to be yet, if that's the variable in the question. So we just need to make sure that it falls within an acceptable range of values. However, the radicand of a cube root can be negative. So you can test this out. Just grab a calculator, and if you take the cube root of, let's say, for example, -8, you will end up with a negative, right? The cube root of a negative number will be a negative, because the cube root says that, well, you have 3, you're taking something and multiplying it by itself 3 times. So I always have to remember that if I do -2 multiplied by -2 multiplied by -2 again, well, 2 times 2 is 4, times 2 gets me 8. The fact that I still have a negative means, well, 2 of them cancel, but I'm always going to have 1 left. So any odd root sign, you can take that root of a negative. It will work. Square roots and powers that are even for your root sign don't work the same way, because all of the negatives will cancel, and it won't end you won't end up with a negative anymore. Solving a radical may introduce an extraneous solution. Called an extraneous root. Basically, all it means is you could potentially get a solution that doesn't work when you substitute it back into the original expression. Right? When we square root a number, we could potentially get 2 answers, the positive version and the negative. So there are some cases where only one of them will actually be the one that works. So for that reason, we need to verify each solution by substituting into the original equation. Okay, so we can plug them back into the original in order to do this. So let's take a look at a couple examples there. So example number 1 says, solve that equation and verify. State any restrictions on our variable. So we'll do the restriction part first. So really we care about the number that's underneath the root sign, right? That's our radicand. And it's a square root, and I know that because I don't see an index there. And I know that my radicand has to be positive for this to work, or 0. No matter what x is, as long as it's a positive number, I can square root it. If it's equal to 0, well, that's also able to be square rooted. So this is okay. There's our restriction. So now we're going to solve this equation. Step 1, isolate the radical. It's by itself on the left side of this equal sign, so that's a good thing. Now I can get rid of it by squaring both sides, which is going to mean x is going to be equal to 121, right? That's 11 squared. And you can double check in your calculator, but there you go. It's also asking us to verify it, so we'll plug it back into the original expression. Now I know this one is going to work because if I do the square root of 121, I'm going to get 11, right? So it is verified. There you go. So this is a pretty easy one to double check. Pretty easy to solve, pretty easy in terms of the restriction as well. Okay, solve this one and verify. This is example 2. And again, state any restrictions. So again, I want to make sure that my radicand is going to be greater than or equal to 0 again because it's a square root. I just need to find the specific value of x where that is possible. So we can subtract a 3 on both sides of that inequality, which will tell us then as long as x is greater than or equal to 3, I'm able to square root this. So if x is 3, that should be negative 3. There we go. So if x is negative 3, plug that into the root sign, well, it will say negative 3 plus 3. They'll cancel. I'll get 0. I could square root it. Any number bigger than that will work. Any number less than x will leave me with a negative in the radicand, so it won't work. So there's my restriction. So when I solve this, my answer also has to fall in that inequality. Okay, it has to fall in that range of numbers. So let's solve this. Square root x plus 3 equal to 14. So radical is isolated again. Square both sides. So x plus 3 is going to equal to 196, I believe. Let me just double check. Okay, so that's good. Subtract a 3 from both sides. So I know the value of x that will make this equation true is 193. And that is a number that is larger than minus 3. So I know this fits. We'll verify it as well. Okay, so x plus 3 equals to 14. So put that number in for x. So 193 plus 3 is equal to 14, which is the square root of 196. 14 is equal to 14, and all is good. Okay, so it does work. Okay, each of the ones underneath we can solve as well. Okay, we won't verify A, B, and C here. We will solve them. Okay, I'll solve each of them. Okay, so step 1, isolate the radical. Right now it's not isolated. There's a coefficient of 5 attached to it. So step number 1 is to get rid of that 5 by the opposite operation. So if I divide both sides by 5, those will cancel the 5s from the left side. 35 divided by 5 is 7. Okay, so the square root of x should be 7. If I now square both sides because my radical is isolated, in order to get rid of my root sign, well, that means x is going to be 49. Okay, and if you think about the restriction here, well, the only thing underneath that radical that's a problem is the variable of x. So as long as x is greater than or equal to 0, we're okay. X is 49, and that's larger than 0, so we're good. For B, step 1 is the same. Isolate the radical. We'll do the restriction first this time before I forget. And again, it's the radicand that you want to make sure is positive or 0. Now, essentially, we're going to solve this little tiny inequality for x. So multiply both sides by 2, which means that really it's just the numerator we care about. X plus 3 has to be greater than or equal to 0. So again, as long as x is greater than or equal to minus 3, we are okay. Okay, there's my restriction. Now, in order to solve this, make sure your radical is isolated. It is. Everything is contained underneath it. There's no coefficient. There's nothing else being added to the root sign. So I can get rid of that root sign now. Let me just write it again here. I can get rid of the root sign again by squaring both sides. So you're going to be left with x plus 3 over 2 is equal to 16. And now I'm left with a couple things to do to solve for x. So multiply both sides by 2. So x plus 3 is going to be 32. Subtract a 3 on both sides. So x is equal to 29. And again, 29 fits with that restriction. It is a number that is larger than negative 3. So we're good. Last one on here is C to talk about in this example. And this one involves a cube root. Now, I know that for cube roots there are no restrictions. So x can be any real number. Okay, it doesn't matter what I get for x, because it's the cube root, it will work every time. So let's think about getting rid of this root sign now. Again, it's isolated, so in order to get rid of my root sign, I can cube both sides of this. I know I'm going to cube it because it's a cube root. So I'm going to be left with x minus 1 is equal to 27, because that's 3 cubed. Add 1 to both sides, so I know x is going to be 28. I didn't have a restriction here, so I know my number will also work. I don't even have to do anything else than that. Okay, there are a couple more here which we'll talk about where the equations start to look a little bit more complicated. So example number 4, and you can see how complicated 5 looks, but we're going to approach them the same way. Solve, state any restrictions on the variable. Again, the only variable here is underneath the root sign. It's a square root, so I want to make sure my radicand is going to be positive or 0. Okay, so the positive coming from the fact that it has to be greater than 0. So if I solve this inequality by dividing both sides by 7, now I know that x has to be greater than or equal to 0. There's my restriction. Now I can solve. So I'll rewrite it, making sure that the plus 3 is really on the outside of that root sign. They are separate. So the first thing we're going to need to do is isolate my radical. So opposite operations say get rid of the 3 first, subtract on both sides, because I want to isolate the radical. I don't want anything else attached to it. 12 minus 3 is 9. There's still a coefficient attached here, so let's get rid of that as well. Divide both sides by 3. So the square root of 7x is equal to 3. Well, now that my radical is isolated, we're going to square both sides because it's a square root. Do that part up there. So I know that 7x is going to be equal to 9. Right? 3 squared is 9. Last step is to get x by itself, so divide both sides by 7. So x is going to be equal to 9 over 7. That is a positive number. It's larger than 0. So I'm good. I'm going to leave it as the exact value for the fraction. I don't want to turn it into a decimal just in case it doesn't end. Because if you do 9 divided by 7, you can see that it goes on for a while. Okay, so I'm going to leave it as a fraction. But there's our solution. Okay, number 5, same question. State restrictions and solve. Again, it's a square root, so your radicand should be greater than 0 or equal to it. So there's one value of x, which is essentially our boundary, where I can't be anything less than it. So let's solve this. Add a 2 to both sides. Divide by 5. So whatever x is, it has to be bigger than 2 over 5 or equal to it. Let me just make that a little clearer. It's exactly the same. There we go. So it has to be equal to 2 over 5 or bigger than it. Anything less than that will leave you with a negative sign underneath your square root, which is a problem. So let me write it out again. And that's equal to 6. Okay. So there's nothing being added to this root sign. It's just this coefficient to get rid of. So let's multiply both sides by 4 to cancel it out. Okay, so we'll multiply by 4, which means we'll multiply by 4 over there. So we'll get 5x minus 2 is equal to 24. We'll square both sides now, which will give us quite a number for 24 squared, which is fine. It's not too bad, 576. So 5x minus 2 equals to 576. If you add 2 to both sides, that means 5x is going to be equal to 578, last step, divide both sides by 5. So x is going to equal to 578 over 5. And again, I'm going to leave it as the exact value because I don't think I can simplify it. Let's see. Well, I might be able to. Oh, no. Never mind. So 578 over 5. I'm not going to write it as decimal. There's your exact answer. So that is the value of x that will make this equation true. That number is larger than 2 over 5, so I know it will fit in my restrictions. Okay, so all of them are very similar. State the restrictions and then solve. Example 6, more of a word type problem. But it just says that, the police can use some skid marks to determine how fast someone was driving. The speed is related to the length of the skid mark, which is in meters. Coefficient of friction, which is given by F, is given by this formula. Determine the length of the skid mark made by a car traveling at 80 kilometers per hour on a road with a coefficient of friction of 0.76. We're going to take everything we have and put it into our formula and see where that gets us. So our formula is S equals the square root 252 distance times friction. So I know a speed is 80. So there's my square root. 252 is just a number. Multiply it by the distance, which is our length of the skid mark, which I don't know. So I'm going to leave it as D. And F is the coefficient of friction, 0.76. Okay, so there's everything I know. So underneath that root sign, I can combine the 252 with 0.76. So I can multiply them together, because everything's being multiplied underneath there. And I get 191.52. So let me rewrite this. So 80 equals 191.52 multiplied by distance. So I really just am going to get rid of the square root here. And again, it's radical isolated, so square both sides. So 80 squared, 6,400, equals 191.52 multiplied by the length of that skid mark. Divide both sides now by your 191.52, and we will end up with 191.52. And it does, I think it should say, it doesn't say nearest tenth or anything. That's okay. So we'll go nearest tenth, we'll round it off. So 33.4 meters is the length of that, the tire skid mark when you hit the brakes. Okay. There we are. Okay, so you can solve this the same way. Think about your restriction here. Your radicand should not be negative. This is a real situation. The length of this can't be a negative number. That wouldn't make sense in this context. So it should be positive, something bigger than 0. Really, what functions the same way as the other ones. We can talk about the last ones here as well. And so essentially, restrictions and solve. Nothing's any different. If you want to try them out right now, hit pause. I'll do them all in the video. That way you can see the solution. But try them out. See how they go. See how you did. Okay, so hit pause right now if you just want to try them. And once you're done, hit unpause and then see how it went. So for the first one, your restriction is x is greater than or equal to 0. If you solve it by squaring both sides, x has to be 16. Okay, which fits in the restriction, that's good. For B, my restriction again comes from the radicand has to be positive or 0 because it's a square root. So I know that 2x has to be greater than or equal to negative 4, which must mean x is greater than or equal to negative 4 over 2. So x has to be greater than or equal to negative 2 for this situation to be true. Solving this now, if I square both sides, I get 2x plus 4 is equal to 36, which means 2x is equal to 32, which means x is equal to 16. Okay, so there is my answer, which fits in my restrictions, so we're okay. Cube root for C, and again we said that if there's a cube root there is no restriction. It doesn't matter what x happens to be. Solving it means I'm going to cube both sides. So if I do that, that means x plus 4 is going to equal to negative 8. Subtract a 4 on both sides, x will equal to negative 12. If you put it back into double check, negative 12 is now x, add 4 to it, take the cube root of negative 8, and you should end up with negative 2 like this says. So this one works as well. So there are some practice ones underneath if you wish to try them. I'll give you the links to them. Like I said, everything will be in the description box, and the solutions will be there as well. So that takes us to the end of our unit on radicals. So I hope those are helpful. You'll find some more videos in the playlists. I'll have them linked to everything, continuing on in our 20-2 course. So if you're going to stick around, we will see you in the next video. Take care.